James Kaufman, World News Report today. Today we're going to do a quick space and solar weather update. We're going to start out here with our KP indexes. These are ground-based measurements of solar wind and plasma hitting Earth. Now the go-to index is the estimated planetary index, and it shows us that everything is all quiet. Now, the only index that we see any type of slight disturbance on is our Boulder index, and it's showing the mildest type of disturbance, a geomagnetic disturbance, seen here in orange, a KP4, not a geomagnetic storm. All the other indexes, the Fredericksburg and College Index, point to, well, no solar winds or plasma hitting Earth dramatically currently. Now, with that said, we've had 4 M-class solar flares today. Although they've been very weak M-class solar flares, I believe the last one is probably the strongest. It looks like it was about an M1.56. We're going to get a better look at these in just a moment, but some of these just barely made it over the M mark on M1.03. But we did have, in fact, 4 Earth-facing M-class solar flares, although they're not the strongest M-class solar flares that we've seen by far. We did have them today. All right, taking a look at the day itself, looks like we come up with our first M flare at about 14:16 UTC time. That peak would be about 7:16 this morning Central Time here in the U.S., and it was generated by a beta gamma sunspot. You can tell by the orange color here, and that was sunspot group AR4197. That was a 1.1 solar flare. Now next we see a 1.2 M-class solar flare generated at 17:11 UTC time. Of course, that's going to be 12:11 just after noon Central Time here in the U.S. That was generated by a brand new named sunspot, 4203, that just came around the limb. Now, what's interesting is the next M-class solar flare that we see here is the M1. It was the M1.03. It was also generated by 4203, the newly named sunspot group. This is a simple sunspot group. You can see that by the green color. And this happened at 2:03, or its maximum was at 2:03 Central Time here in the U.S. Now, since then, we've had an M1.54, the biggest flare of the day, but that has not been assigned to a sunspot group yet, although I am sure we'll be able to see that ourselves on GOES. Today we had a 10% chance of having an X-class solar flare, a 60% chance of having an M-class solar flare, and we did in fact have 4 so far, and a 99% chance of having a C-class solar flare. We have been running a C baseline for weeks. Now I'm going to have to make a strange correction here, but 4203 is this departing sunspot group, and that was responsible for at least 2 of the M-class solar flares. It must have just been named, but you can see that it's almost around the limb there. You can see 4204 has also been named, and we might have some additional sunspots that are named shortly. This is HMI intensogram. 4197 is the only dangerous looking sunspot that we have, beta gamma, and it was responsible for one of the M flares that we had today. So we have a different source here, and it's showing 14 named sunspot groups, including 4203. So it was taken, well, just beforehand. I guess we had some deterioration from one of these groups that doesn't look like much. But this shows 14 Earth-facing sunspot groups, and 4197 is the only beta gamma group, and you can see how complex it does look. 4201 and 4202 also look like they could bring some trouble, along with 4191 and 4199. Headed over to GOES proton flux. We're technically not in a solar storm any longer. Not a geomagnetic storm, which we're not in one of those either. We can tell by the KP index, but we're not in a solar storm. This is GOES proton flux, and we've fallen below the space weather alert threshold here with our 10 million volts of electricity line. Now, we still are experiencing a polar cap absorption event caused by this influx of protons and X-rays, i.e. a solar storm. Over to GOES 19 and solar ultraviolet imager. You can see it is busy, folks, super busy. And I'm going to guess here that this is the last inflare that we just saw here. Now, it very well could be over here on the departing limb, 4203. You can see the activity there. We also have activity on this unnamed sunspot group that will certainly be named shortly. It could be either. And they could be popping off at the same time. They would be called sympathetic solar flares. But it's going to be one of those two. And my guess it's going to be this one, a 1.54, an unnamed sunspot group. Looking at NOAA's KP index forecast for the 28th, 29th, and 30th, they don't expect any activity being solar winds or plasma from any of the solar flares that we've seen pop off. In other words, they do not see a coronal mass ejection inbound towards Earth whatsoever based on this forecast right here. Over to our Space Weather Prediction Center, upgraded by NOAA recently for over $1 million. Today is the 28th. They forecasted almost no plasma. I think they're just about right here. Plasma started the day at about 3, ending the day at about 2 centimeters cubed. And they started the day off on the 28th with solar winds up here at 550 and going down to about 425. Now, I don't think they're going to be right here, but they might be. 550 to 425 and 3 to 2. This is a huge waste of money, along with the hundreds of people that work in Boulder at this Space Weather Prediction Center. All right, I did warn y'all we are in a polar cap absorption event. We do have protons and X-rays pouring in our poles where the Van Allen belts don't protect us. These are those M flares you're seeing as the world turns. And I would think that this would be subsiding based on what the protons are doing. I would expect by this evening this, polar cap absorption event would just about be over. We'll continue to watch it at least through the run here and see if it doesn't start to disappear. It will turn from red to orange and then green and then disappear altogether. That is not occurring. We're still getting fried like eggs. I hope everyone's enjoying the extra X-ray and protons that we're getting in our diet today. Taking a quick look at the back side of our star here. This is the front side with all the active sunspots Earth facing. We do see this reverse polarity sunspot here, and that is the one that they say is beta gamma here. The white over the black is reverse polarity, and so is the black over the white in the northern hemisphere. That is the opposite of what we should see here, and that might be due to the poles of our sun being about to flip. They do flip every 11 years. We should always see white over black in the northern hemisphere, and black over white in the southern hemisphere of our sun. Those would be normal polarity sunspot groups. They say that reverse polarity sunspot groups are extremely rare, but it seems to be all we see lately. What else do we have going on? Well, we've got 016 here, which I think is the cause of what we just named. Cause of at least one of these flares, the one I just pointed out. I don't think it's named yet. We have 019, this absolutely huge, ugly looking sunspot coming around. We have 021 trailing the big red beast, and 022 also trailing the big red beast. Now we'll discuss that this is always about a day and a half old. That's why I'm saying that these are sunspots that we just saw cause that little pop, I believe the 1.58. And, well, furthermore, it takes about 12 days to transit the Earth-facing side of our star and about 12 days to transit the back side of our star, depending on the latitude, believe it or not. All right, over to Discover, our brand new real-time solar wind satellite. Remember, I think they went from 2 to 3 plasma-wise, and from, 550 to 475 solar wind-wise. This is the start of the day here. It looks like they did pretty well with plasma. We do have a couple of anomalies here where plasma actually gets into space weather territory. Looks like there's about 7 or 8 minutes throughout this time period right here that it does in fact creep up over that space weather threshold. But in general, they did pretty well with their forecasts from 2 to 3 in general. Don't know what would cause this anomaly here. We can see that the solar winds also peaked up right there. Now, did the solar wind start at 550 today? No, they didn't. They started at 350. And this is the start of the day here. So 355, 360. And they were supposed to go down to 475. Instead, it looks like they went up so far to 425. So they got that completely backwards and wrong. Although they did pretty well with the plasma. Temperatures are mild. We just have this 1 or 2 hour period here where we have some strange plasma readings, an uptick in solar winds. But no, well, we don't really see the temperature move with it. And real quickly, our shields are basically up here in blue. Protection is up. All right, over to our ACE, real-time space weather satellite, our older of the two. We see that plasma did hang out between 10 and 1 most of the day, except for about an hour and a half, 2 hours of these anomalies here, just breaking through the space weather threshold. You see that the winds jumped up during that period too. I don't know what would cause that. I don't think that anyone could tell you. The temperature did not react. We regularly would see the temperature react there. It reacted here to something, but we don't see the winds or the plasma moving. Generally, we have very mild temperatures here, and they got it, well, completely wrong. This says exactly what Discover said, starting out at 350 and ending up at maybe 400, 425. These 7 or 8 minutes, each dot is a minute, is the only question we have today. You can see that our shields came down for whatever reason during that time period, and that might be the cause here. Hard to say. All right, over to STO HMI magnetogram image. That is one of the sunspots we're worried about right there. Looks like it's regular polarity, white over black. I want to say this is still white over black in the southern hemisphere, which would mean this was reverse polarity. But we could all argue that. This is 02 and 03 right here. I guess this is 01 and 02 right here. and that's O3 over here. And that's the sunspot, if you can barely see it there, that produced that last M flare and has not been named yet. I would like to, question the polarity of this sunspot group here, although it's not very complex at the moment, so we won't worry about it. It says DO HMI magnetogram image, and that was taken, pretty late today, 11 a.m. this morning. So over to SOHO 284 angstroms, the first thing I would look for again was something that looked like a coronal hole, because everyone guessed it would have solar winds, which didn't occur, and there is no coronal hole. But then I would notice that this sunspot is really not far enough around, and I'd look and see that this is 48 hours plus old. So they didn't put up a new SOHO 284 angstroms. That's why we cannot see that sunspot group there, or it would be lit up if they would have put up a picture from today. Sad. All right, again, today is the 28th. They've got plasma down here from about 2 to 3. They got it pretty good guess here. I don't know where they got any of this. This has not been updated in 5 or 6 days or more. The Europeans are not hard at work, we'll put it like that. They had plasma for days up above 20 and 25 centimeters cubed, but no plasma was inbound. Now, please notice here on the 28th, we have that same mess with the space agency. This is the ESA, the European Space Agency, and their Euphoria. And they also guessed that solar winds would be up above 500 kilometers per second, and they would drop down to about 450. But solar winds are nowhere near that. Again, it's like they saw a coronal hole that wasn't on the sun, at least that we could not see. So they have the same prediction basically as the Space Weather Prediction Center here, but it's completely wrong. If you recall, we just looked at both satellites, and the solar winds, they started out at 425 and went up to 450, something like that. Here they have them starting at over 500, just like they did on the Space Weather Prediction Center, and going down to about 450, just like they did. You would have to have a coronal hole, the only thing that would pour out solar winds like this. Solar flares and filament eruptions both produce plasma, which is this up here. And you can see the plasma going in every direction, Earth being here in blue. I really didn't see it get hit. Everything was backside, as you can see. Off the chart, 60 centimeters cubed, but there's a glancing blow off of one of the deals, and they just must have gotten it completely wrong. I have no idea why both agencies forecast these solar winds that just weren't there. There was no coronal hole, no canopy missing, no black hole in the sun that we were able to see on any of our instruments. All right, we did have I think a 5.7 earthquake up in Alaska today. We have a pretty decent lineup still here with the moon back here. I did see someone else cover RCA, their report they put together for the military. Nelson is the scientist that did it, and he was let go because of it. He's been 95% correct since releasing that report in 1948, and scientists still pretend like they can't predict what's going to happen when in fact I seem to be able to just by reading his report. All right, big watch days. We've got the 9th and 10th here. The 9th and 10th, maybe the 11th, and then we connect to Uranus. That's that 90-degree and the lineup that Nilsson addresses. This is a bad situation, and the moon, of course, is his most important factor. And that takes us into the 20th, 21st, and 22nd. So the 8th, 9th, and 10th, and the 20th to the 22nd, huge watch times for us. In summary, we've had 4 M-class solar flares, although they didn't really count because they just barely made it into the M-class territory. We have no solar wind or plasma hitting the planet, although both the ESA and the Space Weather Prediction Center at NOAA said that we should be being hit by solar winds from a coronal hole, which didn't happen. And, well, I guess we're waiting to see if any of these sunspot groups are going to fire without a gas giant involved and without the moon involved, which we won't really have until about the 9th. So I'm not saying they won't. I expect them to fire. But I'm just saying that the chances are, come the 9th, 10th, and 11th, come the 20th, 21st, and 22nd, that we're going to see a lot of activity. I'm talking about solar activity, talking about earthquake activity, and I'm talking about volcanic activity. God bless you guys. Please share our videos. Please subscribe if you have not. And always remember, anything's possible. Bizarro world.